So now we're simplifying radicals with a higher index. Cube roots and fourth roots and fifth roots and so on and so forth. The principle is the same. The difference is the perfect whatever it is we're looking for. When we started with square roots, we're looking for perfect squares. When we have cube roots, we're looking for perfect cubes. So we have here the cube root of 27. Now some of these we might have to figure out, but we should know that 27 is simply 3 cubed. So in other words, this equals the cube root of 3 cubed, and the cube root of any value being cubed is that value. So the cube root of 27 is 3, and that's again because 3 times 3 times 3 equals 27. 3 times 3 is 9, times 3 is 27. Now the fourth root of 256, this one we might not recognize right off the bat. You can factor it to look for, are there any factors that are multiplied by themselves 4 times? You should eventually be able to recognize from doing these problems that 4 to the fourth power equals 256. And if we want to check that, 4 times 4 times 4 times 4, that equals 16 times 4 times 4, or 16 times 16, which equals 256. So this is going to equal, and I've got a little off sideways here, so I'll bring it over here. The fourth root of 256 equals the fourth root of 4 to the fourth power. The fourth root of any power, or of any value to the fourth power, is simply going to be that value. So the fourth root of 4 to the fourth is 4. Now with part C and fifth roots, we're getting into an area that we're really not going to recognize right off the bat fifth roots. So we want to look at factorization. We want to look at what factors. If we don't recognize what value to the fifth power is 243 right off the bat, what factors we can divide by to see, well, what are all of the factors of 243? So if we recognize 4, 5, 6, 7, 8, 9, if we add the digits up, 2 plus 4 is 6, plus 3 is 9. So we know that this is both divisible by 9 and divisible by 3, because 9 is both a multiple of 3 and a multiple of 9. And when the digits add up, those two values that are multiples of 3 or multiples of 9, they're divisible by 3 or 9. So let's look at first 243 divided by 3. That's going to be 81. Well, we know 81 is divisible by 3 as well, so let's look at 81 divided by 3. That's going to be 27. Well, we know 27 is divisible by 3. This is starting to look pretty good. 27 divided by 3 is 9, and 9 is 3 times 3. So 9 divided by 3 is 3. Well, how many 3's is that? That's 1, 2, 3, 4, 5. So 3 to the fifth equals 81. So we can rewrite this as the fifth root of 3 to the fifth. The fifth root of any value, any real number being raised to the fifth power, is just going to be that real number. So the fifth root of 3 to the fifth is simply 3.